In this video, I'll be sharing with you 3 mini Python projects for intermediate programmers. These projects are designed for people that have some experience with Python, they understand the basics like if statements, for loops, functions, etc., and they want to build something a bit more complicated that doesn't take a ton of time. Each of these projects will take between 20 and 30 minutes for us to build out. They'll be under 100 lines of code, yet they'll still be more advanced than kind of a beginner project and a lot of the other stuff that I have on this channel. So with that said, let me give you a quick demo of the 3 projects and explain what you'll learn in them, and then we'll get into actually building them out. So the first project that we're going to work on is a Pathfinder or a Maze Navigator. I'll just run the code and kind of explain how this works. So you can see it actually takes over the entire terminal here. We have a maze, and you can view what's known as the breadth first search algorithm going through here and trying to determine the shortest path between one point and another. Now you can customize this however you like, but I'm going to show you how we can control the terminal like this, have different colors, and then override what's currently on the screen as opposed to constantly printing stuff out. This is really cool. It's also really simple to do. And then, of course, I'll walk you through the pathfinding algorithm, which is kind of a very famous algorithm that you learn in any computer science class. Again, it's called breadth first search, and I'll explain to you how that works. So that is the Pathfinder or the maze algorithm, whatever you want to call it. The next thing that I'm going to show you is a little bit simpler, but this is how you can get data about NBA games, so basketball games. So the current games that are running, what time they start at, as well as viewing stats and all kinds of other information about players, teams, etc. I've built this out just to show you how to work with an API, and then of course you can customize this and change it how you like. But if I run the program right now, you can see that what it gives me is a list of the teams ranked by their points per game. So we have all of the different teams, and they're ranked currently by number of points that they average per game. That's one functionality that we can use. The other one is to get the current scoreboard of the teams. So let me just change the function here, and let's run this. And what this prints out now is all of the games that are upcoming, what time they start at, and then if the game was currently running, it would show you what period it's in, the time on the clock, and then whatever the score is in the games. Now, of course, none of these are running right now when I'm running this, but if they were going on, then you would see the information, and every time you rerun this, it'd be updated in live time. So kind of a cool project, especially if you're into basketball. And then the last one here is a currency converter. So let me run this project here. You can see we get welcome to the currency converter, and then we have 3 commands, list, convert, and rate. So I can enter a command. Let's start with list. This lists out all of the currencies. Then what I could do is maybe convert. So let's say I want to convert the currency of USD, maybe $100 in USD to Zimbabwean dollar. So let's try that, ZWL. Okay, it gives me 100 USD is 32,199 ZWL. I could also get the rate between different currencies. So enter my currency CAD and USD, and then notice this is the current exchange rate. So that's what you can do with the currency converter. All of these projects you can add to and make a lot more advanced, but this is a really good starting kind of foundation and teaches you how to work with APIs and do some more advanced things that you wouldn't learn in a beginner tutorial. So hopefully after seeing the demo for these projects, you guys are excited for this video. If you are, make sure you leave a like. I will mention all of the source code for these projects will be available in the description, and we'll get into them after a quick word from our sponsor. Before we dive in, I need to thank Altium Designer for sponsoring this video. Altium Designer is the world's most trusted PCB design system that enables engineers to effortlessly connect with every facet of the electronics design process. Altium Designer has used 35 years of innovation and development to create a truly unified design environment that makes it the most used PCB design solution on the market. Altium Designer provides an intuitive and powerful interface that lets you design PCBs rapidly while interacting and collaborating with your mechanical designers. The interface provides a photorealistic 3D environment, collaboration and synchronization with tools including SolidWorks, PTC Creo, and Autodesk Inventor, realistic rigid flex designs, multi-board assembly, and much more. Altium Designer is the most popular ECAD tool and electronics design software, and you can get started with it today for free by pressing the link in the description and registering for a free trial. Thanks again to Altium Designer for sponsoring this video, and now let's dive in. All right, so let's go ahead and dive right in. Now I'm going to start with the Pathfinder or the Maze Navigator, whatever you want to call this, and we're going to use a package here called Curses, which allows us to control the terminal and color it in the way that you saw and actually override what's currently in the terminal so that we don't have to keep printing a bunch of separate lines and kind of having a really messy standard output. Now, if you're on Mac or Linux, Curses should be installed by default for you, but if you are on Windows, you're going to need to install this. So go to your terminal. I'm just in VS Code and I've opened up a terminal here, and you're going to type the following command, pip install, and then Windows-Curses like this. Now, again, you only need this if you're on Windows, so hit enter. Try that command. That should install it for you. And if for some reason that doesn't work, I'm going to give you 2 or 3 alternative commands. You can try pip3 install Windows Curses. If that doesn't work, you can try python-m pip install Windows Curses. And if that doesn't work, you can try Python 3. Now, if none of those work, I'll leave 2 videos on the screen that should show you how to fix this pip command, one for Mac and one for Windows, although I guess you only really need it for Windows because you don't need to install anything if you're on Mac or Linux. All right, now what I've done is made a Python file here called pathfinder.py. I've opened it in VS Code. You can work in any editor that you want, but I'm going to use VS Code. I've also pasted in a maze. You can find this maze from the link in the description on the GitHub repository, or you can just make your own maze. I'm treating all of the pound sign here or number sign here as my obstacles in the maze. All of the empty strings are going to be things we can navigate, and then the O is going to be our start, and the X is going to be the end. Now, I do want to mention here that if you are trying to get better at Python, you also can check out a product I have called programmingexpert.io. This is a programming course, teaches fundamental programming, object-oriented programming, advanced programming, software engineering tools, all kinds of stuff. Just wanted to mention that. If you guys are interested, you can use discount code TIM. I'll leave that in the description. For now, though, we do want to build out this project. So we have our maze here. And the first thing I'm going to do is I'm going to import that Curses module and quickly walk you through how this works so you can see how we can print colored output. I do also have an entire tutorial series on the Curses module on my channel in case you are interested. I'm also going to say from Curses like that, import, and I'm going to import something called wrapper. And then while we're up here, we're going to import a queue. This is built into Python. You don't need to install it. And we're going to import time just so we can implement a bit of delay here in this program when we start actually trying to visualize things. For now, though, I want to show you how the Curses module works. So what we need to do here is define a main function. And this main function needs to have as one argument std_scr. Now, this stands for standard output screen. And this is what we're going to use to actually output all of this stuff for our program. So rather than using the standard print statements here, we're going to add stuff to this screen. This screen is going to override and kind of take over our terminal. And then as soon as the program ends, everything on that screen will be cleared and will be brought back to the original terminal. You'll see what I mean in a second. But for now, we're going to type the following, stdscreen.clear. So we're going to clear the entire screen. Then we are going to not write, but we're going to add string. And when we add a string to the screen here, we have to pass the position that we want to enter this string at, or that we want to add it to. So for now, I'm going to go 0, 0. That represents the top left-hand corner of the screen. So I believe we're going row and then column that we want to enter this in. I'll experiment in a second. Then whatever the text is that we want to show on the screen. So in this case, I can do hello world exclamation point. Then we're going to do stdscreen dot, and then this is going to be refresh. And what that does is refresh the screen. And so we actually see what we wrote. And then lastly, I'm going to say stdscreen dot, and this is going to be get ch. What this stands for is get character. And this is similar to an input statement that we would have in Python. It just makes it so that we're going to wait here until the user hits something before we exit the program. If we don't have that, it would do this and then just instantly exit, and we wouldn't see anything because we weren't waiting long enough to actually view the output. All right, now that we have that main function, we're going to call wrapper, which we imported up here. And we're going to pass to it the name of this main function, but we're going to make sure we don't call the function. So I'm not calling it like that. I'm just passing the name of the function. And what this does is it initializes the Curses module for us, and then it calls the function, passes this stdscreen object, and then we can use that in here to control our output. All right, hopefully that's clear so far. Let me save and let's run the code and let's see what we get. And notice that it kind of brings me to this blank window and it says hello world. And then if I hit any key on my keyboard, brings me back to the original terminal. One more time, if I run this, notice it shows me hello world, hit a key, and then I'm out. That is the Curses module, very basic introduction. However, I want to show you what happens when we change these coordinates and how we can add colors. So let's say now we maybe draw this at 5. So 5, 0 is our position. Let's run the code, and notice we go 5 rows down, and we're at the 0th column. So that's how you can control where you're drawing this. You put the row and the column you want to start drawing. So if I go maybe 5, 5, and then let's save and rerun, save and rerun, notice we get hello world kind of more in the center of the screen. So very powerful what you can do here. And then if we want to add a color, This is a little bit more complicated. We first need to initialize a color. So I just got to look at my cheat sheet over here to remember how to do this. So we're going to say curses.init_pair. And whenever we create a color pairing here in curses, we give it an ID. So I'm just going to give an ID of 1. And then I put the foreground and the background color that I'd like to have. So I can say curses dot and then color underscore and then whatever colors. You can see there's a bunch of options here: green, magenta, red, whatever. So let's go with blue for now. And then the foreground color, or sorry, the background color, my bad, is going to be curses underscore color and then black. So you put your foreground color and your background color. Pretty much all the colors you can think of are, you can access them with color underscore their name. And then now that we have the initialization pair, if I actually want to use this color, what I have to do is the following. I'm going to say blue underscore and underscore black is equal to, and this is going to be curses dot, and I believe this is color pair. Again, let me just have a quick look at my cheat sheet here to remember this. Yes, it's color pair. And we're going to put the ID of the color pair we want to use. So since I referenced this with ID 1 or created it with ID 1, now I reference ID 1, and that's going to give me a color of blue and black. And the way I apply that now to my text is I just pass another argument to add string with this, so blue and black. And now when I start displaying this, it should be blue and black. So let's do this. Let's run the code. And notice I get hello world in blue text, and the black is just the default background, so it doesn't change the background color. But if I wanted it to be like a white background, then I would say color white. And then if I draw this now, so let's rerun this, notice I get kind of a white background for that text. Great, but let's go back to color black. Okay, so that's the first color pair. While we're here, let's initialize another color pair because I want blue and black. I also want red and black. So let's change this to red and let's make that 2. And then we'll use these later on. I don't actually want to write hello world onto the screen. So let's actually just comment all of that out for now. And let's work on the breadth first search algorithm, and then we can actually start displaying stuff on the screen. So the first thing I want to handle is printing this maze out. So obviously I want to view the maze on the screen. So to do that, well, how am I going to do that? I'm going to write a function here. I'm just going to call this print maze. And to be able to print the maze, I need the maze that I'm going to print. I need the standard screen or the standard output screen that I'm going to print the maze to. And then I'm going to take a variable here or an argument called path. Now path is going to be the path I want to draw on the maze. Obviously we don't know what the shortest path is yet, but I can pass a path here of coordinates, and then whatever values are in that path, I'll draw them a different color in the maze. So you'll see what I mean in a minute. So that's print maze. Now inside of here, I'm going to grab my 2 colors that I want to use. So I'm just going to say blue is equal to, and then this will be curses dot color underscore pair. And this will be 1. And let's say red is equal to curses dot color pair 2. Just so I can use both the blue and the red. We'll draw the default maze as blue and then the path as red. Okay, continuing, I'm going to loop through everything in my maze because this is a 2-dimensional array. So I have kind of all my rows, and then the columns would be the individual values in each row. So I'm going to say for, and this is going to be I, comma, row in enumerate maze. Now, if you're unfamiliar with enumerate, this is going to give me the index as well as the value. So I'm going to get every one of these rows as a row, or every one of these nested arrays as a row, and then I will be what row I'm currently on. Okay. Continuing, I'm going to say for j, comma, value in enumerate, and then I'm going to enumerate over the row. The reason I can do this is because I have a list or an array, whatever you want to call it, but list in Python. So row is my list. Then I'm going to enumerate over the list that I have. I'm going to grab whatever column I'm currently on, which is what J is going to represent. And then the value is going to be whatever symbol here is in the column. Okay, so that's what I have. Then what I want to do is I want to simply draw this onto the screen. So I'm going to do the following. I'm going to say std screen dot, and we're going to add string. And now we need to determine where we want to add this string. Well, where I want to add it onto the screen is going to be whatever position I'm currently on, which is going to be represented by I and J. So I is going to tell me the row I'm on, J is going to tell me the column. So what I can do is simply add whatever I'm drawing here at whatever row and column I'm currently at. So I'm going to say IJ as the position, and then I'm going to say value, and value is just going to be either an empty string, a number sign, an O, an X, whatever it is that I'm currently looking at. Hopefully that makes sense, but that's what we want for print maze, and then I'll handle the path in 1 second. For now, though, let's actually try printing the maze. So I'm going to uncomment the clear. I'm going to uncomment the refresh and the get ch. And now, rather than adding my own string, I'm going to call print maze. I'm going to pass to it the maze variable, which is just a public variable or a global variable. Well, that's fine. I'm going to pass my std screen. And then this is a default argument of empty list, so I don't need to pass that. Okay, so let's run this now. Let me just make the terminal a bit bigger first. Let's run this, and notice my maze is printing out. Now, this looks a little bit squished together, like it's too close to me. So to spread this out a little bit, what I'm going to do is simply multiply the row and the column that I want to draw this at by 2. And actually, we can leave the row as just regular I. We can just spread the columns out a little bit more. So now we should get kind of 2 spaces between each of our elements. And also, let's add a color here. So let's add blue, and now it should be drawn in blue. So let's run this. And I guess I need to run again. Okay. And there we go. That looks a lot better. The maze is spaced out, and we can kind of see it all nice. Great. So let me exit that. All right, so now that we are printing the maze out, and I guess that's pretty much all we're doing, I need to talk a bit about how this algorithm works. So let me head over to the whiteboard. I will explain that to you, and then we'll start coding it out. So in front of me, I have a very simple maze. I'm also going to refer to this as a graph, and this is what I'll use to demonstrate the breadth first search algorithm. So the goal here is to find the shortest path from some starting node to some ending node, and I'm going to reference these nodes by their position in the graph. So we see these are different rows, these are different columns, and I'm going to have my positions in row column format, which means I would refer to this here as 1, 0, so row 1, column 0. Just keep that in mind as I write the positions, because you might be confused if you're reading it the other way. And like here, this would be 0, 3. All right, so how does the breadth first search algorithm work? Well, the concept behind the breadth first search algorithm is that we're going to continually expand outwards from a point until we find the ending point that we're looking for, or the ending node. I'm just referring to every single one of these squares as a node, okay? In kind of graph theory, that's what you would call them. So we're going to start here at this start point, and we're essentially going to slowly expand outward by looking at all of the neighbors of this point. So we're going to look at this neighbor, and if there was a downwards neighbor or a left neighbor, we'd look at those as well, but there isn't any left or down neighbors, so obviously we're starting here. So we expand here, and then from both of these points, we're going to look at all of their neighbors. So maybe we start with this one, we would look at this neighbor, then we would look at this one, and then we continue the process. And we do this one iteration at a time, which means that once I finish considering this neighbor here, I go and I do this one. Then, of course, we're going to move up to here, we're going to move up to here, and since we're doing this one step at a time, as soon as we hit the ending node, we will actually be guaranteed to have found the shortest path, because we're only expanding our path from the starting node by one new node at every single iteration. Now, that's a super high level recap of how this works. Of course, I'm going to walk you through the code in a more complicated demo, but that's kind of the concept here. One step at a time, we're slowly expanding outwards from this node and expanding our current path by 1 until eventually we reach this end node. And as soon as we find the end node, we know that we have found the shortest path, because every other path that we have is either going to be the same length or longer to find this path, okay? So let's now look at a demo of how we actually do this. So first of all, we're going to use a data structure called a queue. Now, queue, I believe, is spelled like that. I'm also just going to refer to it with the letter Q. And this is what's known as a first in, first out data structure, or a last in, last out data structure, whatever you prefer to call it. Essentially, what that means is that if I enter some item into the queue, just kind of like a phone queue or any other lineup that you would be in, if I entered this item first, then this is going to be the first item to come out. And the second item that I enter into the queue, that's going to be the second item to come out. Now, that's important because we're going to process elements in the order in which they're entered into the queue. So just keep that in mind. So for our queue, we can have a back and a front. So we can say that this is the front of the queue, excuse my messy handwriting, and then this is the back, just so we're clear on kind of what element we're going to process next. So what we're going to start by doing is we're going to place our starting node here inside of the queue. Now, the way I do that is I just place the position of the node that I want to start looking from. So I'm going to put a position of 3 and then 0 because it's in row 3 and column 0. Now, every single step in my algorithm, what I'm going to do is I'm going to pop an element off of my queue. I'm going to take the element that's currently at the front of the queue. I'm going to remove it from the queue, and I'm going to start processing it. Now, the way I process an element is I essentially just look at all of its neighbors and try to find if we're currently on the end element or not. So in this case, I take 3, 0 off the queue, and I say, okay, I want to process all of this element's neighbors and kind of expand outwards from this. until eventually I get to this node. So what I'm going to do is look at the neighbors. I'm going to determine I have 2 of them, and I'm going to check if these neighbors are the end node. If they are, then I'm done the algorithm. I found the shortest path. But if they're not, what I need to do is add them onto the queue. So now they can be processed and we can continue expanding until eventually we find this end node. So let's erase this from the queue here. So 3, 0, we've now processed that element. I'm going to add this into some set here. So let me just create a set. This set will be known as our visited set. And okay, it's kind of hard to draw this the way that I want to. So let's just do this, 3, 0. And the reason I'm putting it in a set is just so I know, okay, I've processed this element. I don't have to look at it another time. Anyways, processing the element again involves looking at all the neighbors. So the 2 neighbors here are 2, 0. And what do we have? We have 3, 1. So I'm going to add those positions into the queue. Doesn't matter the order that I add them in. So I'm going to add 2 and what was this? 0. And then my other one is 3 and 1. Okay, so these are now the 2 new elements that I need to process to continue expanding my path. So what do? Well, I'm going to pop now the first element off of the queue, and I'm going to process this one and, well, repeat everything that I was doing. So let's cross it off. We'll erase it in a second. This is the current one that we're looking at. So now we need to consider all of this node's neighbors. Now it has a neighbor down and a neighbor up. It also has one to the right, but since the one to the right is an obstacle, we don't look at that. And for the one that's below us here, we see that the one below us is an element that we've already looked at. And the reason we know that is because it's in this visited set. So I can skip the neighbor below us because we've already looked at it. I don't need to process the same element twice, and I can just go directly to the element above. So I'm going to add a single neighbor here to my queue, and this neighbor is going to be in 1 and then 0. So now I've processed this element. It was not the final node that we were looking for, so let me delete it here. And now we're going to add this into this visited set. Now I didn't mean to butcher my element here, so let's go here. What was that position? That was 2 and 0. So let's add this in, 2, 0 like that. And now we've visited those 2 nodes. Now we're going to continue. So we're going to take the next element off of the queue, which is 3, 1. So I'll just delete it here. We will add it into this set. So you might as well just add it right now. Okay, 3 and 1. And then from 3, 1, that's right here, we need to look at all of its neighbors. So it has one going to the right and it has one going to the left. Well, of course, the one to the left we've already processed, so we can just add the one to the right, which is right here, and that has a position of 3, 2. So what I do is I add 3, 2 to my queue. If we can, that's a really bad 3, but you get the point. We add 3, 2, and we continue. And this process is going to repeat until eventually we hit this end node. And again, as soon as we hit this end node, we know that we found the shortest path because that's the first time we found it, and we would have found it on another path if there was a shorter path to get to it. So, I mean, I could continue this example, but hopefully you kind of get the idea. We're expanding outwards one node at a time until eventually we find the ending node, and then I will show you in the code how we actually kind of keep track of what path we were on, because that is a little bit more complicated, but this is the basic idea. We have a queue, we add elements onto the queue, we process them one at a time in the order in which they were inserted into the queue. This guarantees that every kind of new element that we're looking at is only expanding our current path by at most 1 node. As soon as we find the end node, then we can just say, okay, well, we found the shortest path, let's end the algorithm, let's draw the path out. Hopefully that gave you a very brief explanation of how this works. I don't want to go through the whole thing because it will take too much time. Now though, let's start coding this out and hopefully everything will be cleared up. All right, so let's code out a function here called find_path. And we're going to take in here the maze, and then this is going to be the standard screen. And I think that's all we need for find path. Now for find path, I'm just going to declare a few variables here. I'm going to say start is equal to X, end is equal to O. And actually, is this, no, we're going to say start is equal to O, end is equal to X. And what else do we want here? We want to figure out what the starting position is of our maze. Now we could just hard code in the position right here, but instead I'm going to write a function that will essentially look for this O and tell me where in my maze I'm starting from, because we're going to start from this position. We need to know the coordinates of this, right? So in this case, it'd be 0, 1, 2, 3, 4, 5. Okay, it's in row 0, so it would be 0, 5. That would be the position here of the start. But we want a function that will tell us that, so we don't have to manually do that. So for now, I'm going to say define find_start. And just because I didn't really explain this, I just jumped right in. What we're doing here is we're going to start coding out that breadth first search algorithm that you just saw. So that's what find path is going to do. But first we need to find the starting position. So we're going to take in the maze here, and we're going to take in whatever the starting symbol is. And what I'm going to do in here is simply say for, and this is going to be I, comma, row in enumerate maze, and then for j, comma, value in enumerate row. I'm going to say if the value is equal to start, then I can simply return I, comma, j. So I'm going to return the row and the column where I found this starting symbol. And we're going to assume that we just have one of those symbols. Okay, now otherwise, we'll just return none if for some reason we couldn't find the start. Okay, so now in here, we're going to say start underscore pause is equal to find start. And then we're going to call the maze and the starts. Now we know the starting position. Now what we want to do is set up our queue and set up those iterations and finding the neighbors and all that stuff I was discussing. So for the queue, we have this queue module and we're going to use it. So the way we do that is we're going to say queue is equal to, and then queue.queue. And again, this is a first in, first out data structure. So the first element I insert is the first element that comes out. That's very important because the order in which we process the nodes really matters when we're doing the breadth first search. We don't want to process the most recent node we've added to the queue. We want to process the node that's been in the queue the longest, just like we would if you were accepting, a bunch of phone calls or if there was a lineup or something like that. That's exactly what a queue is, right? So we have our queue and we need to insert something into the queue. So to insert something, we use this put method here, and we're going to put a tuple, and the tuple is going to contain the starting underscore position. And it's going to contain a list that has the start underscore pause in it. Now, the reason why we're adding two elements in here is because in the queue, I want to keep track of the current position or the node that I want to process next, as well as the path to get to that node. Now, the reason I want the path to that node is because as soon as I find the ending node, I'm going to take whatever path I currently have, and I'm going to start drawing that onto the screen. I'm going to show that on the screen. So for now, since we haven't found the end node, our current path just includes the start position, but every time I process a new neighbor or something along those lines, I'm going to change the path, and the path will continue to grow, and I'll be able to see what path we're at for every single node. Hopefully that makes a bit of sense, but that's why I'm storing two pieces of information, the position I'm currently on, as well as the path. And in fact, we could even optimize this further and just store the path and grab the last element from it. But I'm just going to do two things here just so it's crystal clear when I code this out. It's not the most efficient thing in the world, but for this tutorial, it's fine. Okay, so for now, we put that in the queue. We also want to make a visited set, which is going to contain all of the positions that we've currently visited. Now that we have all that set up, I'm going to say while we still have any elements in the queue. So while not, and then queue dot, and I think this is either is empty or just empty. I believe it's just empty. So while the queue is not empty, what we're going to do is we're going to get the most recent element from the queue, the one that's kind of next in queue. So I'm going to say current underscore position and path is equal to queue.get. Now get's just going to give me the element at the front of the queue. And since I have two things for every element, I have my path as well as the position. I'll grab the current position, which will just give me the first element, and the path, which will give me the second element. Okay, now that I have the current position, I'm going to say the row and column is equal to current position. So I'm going to break down the position into its two components, the row and the column. And I'm going to find all of the neighbors of this position and start processing them if they are not the end node. So first I'm going to say if maze, and then this is going to be at row call is equal to, and this is going to be the end. So we're going to say end like that. So we're going to look in the maze and see if this position is equal to an X. If it is, that means we found the end. And so what we can do here is simply return the current path. Because again, as soon as we find the end node, we know that we've found the shortest path or one of the shortest paths, because there could be two paths that are both the shortest. We'll find one of them, so we can just return the path, and then we can draw that if we want. Okay, continuing. Now what we need to do, if we haven't found the end node, is we need to continue branching out. So we need to find all the neighbors of the current node and then expand towards them. So we're going to write another function here called find underscore neighbors. Now the tricky thing with the neighbors is that we need to make sure that the neighbor that we're finding is not an obstacle and that it's a valid position in the maze. So you'll see what I mean here, but we're going to take in a maze, a row, and a call. And we're going to say our neighbors is equal to an empty list. And we're going to determine programmatically what all the neighbors are of this current position. So we're going to look up, left, right, and down. If you wanted to, you could do diagonal, but I'm not doing diagonal in this tutorial. But adding that is fairly easy. So for now, I'm going to say if the row is less than, not 0, sorry, if the row is greater than 0, then I'm going to add a neighbor. And this neighbor will be the neighbor above. I'm going to say neighbors.append, and I'm going to append the row -1 and then the current column. So we can add a comment here and say this is going to go up. Now, the reason I have to check if the row is greater than 0 is because if the row currently is 0, I have no more rows to look up. I'm at the bounds of my maze, and so I can't add that. But if the row is greater than 0, so it's 1 at minimum, then I can subtract 1 from it, and that's still a valid position. Next, I'm going to say if the row, and this will be +1, is less than the len of the maze, then I can add the row below. So I'm going to say neighbors.append, row +1, and then call. Again, because if the row +1 is equal to the length of the maze, then that means if I were to add row +1, I would get an index out of bounds error. I'd be too far. That means I'm already at the bottom of my maze. But if this is true, then that means I can add one more without going out of bounds. So that's for the rows. Now we want to do the same thing with the columns for left and right. So I'm going to say if the column is greater than 0, then this is going to be left. What I can do is say neighbors.append, and I can append the current row and the column -1. Okay. And I'm going to say if the column +1 is less than the len of maze 0. Now, the reason I need to check maze 0 is because my maze may not necessarily be square. In this case, I don't actually think it is square. We may have more columns than we have rows. So I need to check how many columns we have, and I can just do that by grabbing the first row and seeing how many elements are in there. So that's what I'm doing here. If we don't have a first row, this will cause an error, but we're always going to have first row, so that's fine. And then I'm going to say neighbors.append row and call +1. And then here I'm going to return neighbors. And let's just put a comment here for right. Now in here, we did not check if these positions are obstacles. We'll do that inside of here. For now, we've just got all of the valid positions that are neighbors. Now we're going to check if they're obstacles or not as we loop through them. So I'm going to say neighbors is equal to, and then this is going to be find neighbors, not find path, find neighbors. And we are going to pass to it the maze, as well as the row and the column of the current position that we're processing, right? Finding all of their neighbors. We're then going to say for neighbor in neighbors, and we are going to check if this is an obstacle or not, and if we've already visited it before. Because if we've already visited it, we don't need to process it. So I'm going to say if the neighbor is in visited, then continue, because we don't want to process it. And I'm going to say if the neighbor, and actually, sorry, I need to break this down. I'm going to say row call is equal to neighbor, and actually we'll just go RC so that we don't shadow the variable name up here. But I'm going to say RC is equal to neighbor, standing for row and column. I'm going to say if the maze at, and this will be RC, is equal to a £, okay, then what we want to do is continue, okay? Now, if this is not the case, so if the neighbor's not in visited and the neighbor's not a £, then that means we need to process this neighbor. So I need to add it to my queue. So I'm going to say queue.put, and I'm going to put inside of here my position. So I'm going to put the neighbor, okay, which is just going to be a tuple containing the row and column. And I also need to put the new path that now contains this neighbor. So I'm going to say my new path is equal to, and this is going to be whatever the current path is up here. Okay, so where do I have path? Path is right here. And then this is going to be plus, and inside of another list, because I can add two lists together, I'm going to put the, the neighbor. So all this is doing is kind of tacking the neighbor onto the current path. This is not the most efficient possible way to do this. You guys can try to optimize this if you want, but for now, this is fine. And for the simplicity of the video, I'm going to do it in this way. And then I'm going to put new path. So I'm adding the neighbor as well as the new path. And the new path is just whatever the current path is plus the current neighbor that I'm considering, right? That's what I have when I'm adding to the queue. Okay, hopefully that makes sense. Lastly, what we need to do is say visited.add, and we add the neighbor to that to make sure we don't process it multiple times. And that's actually all we need for the breadth first search algorithm. Again, I know this looks pretty complicated, but that's all we need. Now what we want to do is make it so that we draw all of this stuff out so we can kind of see this happening. And then I'll walk through the algorithm one more time just to make sure it's crystal clear. So where we had this here, right, where we were printing the maze, I'm going to copy that and I'm going to put that inside of this while loop, because at every step, I want to draw out what I'm currently considering. So I'm going to go up here and I'm going to paste this before we're checking if we're at the final element or the final node. And I'm going to print the maze, except this time I'm going to pass my path. And when I pass the path, now this will allow me to draw out the path, right? So I'm going to clear the screen, I'm going to print the maze, and I'm also going to add something to print maze so we draw the path. And then I'm going to refresh the screen, and I'm going to do this every while loop iteration so that I can see the progress going on as I go through this algorithm. So now let's go to print maze, and let's make it so that we print the path in a different color. So here I'm going to say if, and this is going to be I, comma j, is in the path. So if it's in the path that we have right here, that's valid to check that. Then what I want to do is draw this in a different color. Otherwise, I'll do this. So I'm just going to copy this line. I'm going to paste this in here. I'm going to change from value to be X because X is going to represent the current path. And I'm going to change the color to be red. So now rather than drawing an empty string, I'm going to draw an X and I'm going to draw it in red, and I'll draw it at the same position I would have before. But again, we're just changing what we're drawing. Okay, so that's pretty much all we need. The last thing we need to do here is just call this function. So this function is find path, and it takes in the maze and the STD screen. At least I believe that's correct. And I think with that, this should all work. Now there's a chance I made a mistake and we'll have to fix that, but for now, let's run the code and give this a test. So let's make the terminal nice and large. Let's run this, and notice it just instantly found the path. And we get that. Now, of course, we want to be able to visualize this, so we can make it a bit slower. And the way we can do that is by using this time module. So if I go here where my refresh is, pretty much anywhere in here, what I can do is time.sleep. And I can sleep for like 0.2 seconds, 0.5 seconds, whatever you want, just so that you have some time to kind of process what's going on. So let's sleep for 0.2. Let's make this larger and let's run this. And notice that now you can watch the breadth first search algorithm in action and see every path that it's currently considering. And there you go. We just found the finished path and the algorithm is done. All right, so there you go. That project is now finished. Was a bit longer than I was expecting, but obviously I wanted to explain this as best as I could. Let's walk through it step by step to make sure everything's clear, and then we'll move on to the next one. So we start here with main. We've already talked about curses. We know how this works. And we call find path. Now we call find path, we pass the maze and the standard screen. And inside of find path, the first thing that we need to do is determine where the start position is in our maze, because we're using coordinates, right? And we're trying to use that, so we need to know the starting position. So inside of find start, we just loop through the maze. So we go through all of the rows, we go through all of the values in each row. And if we find a value that's equal to the start symbol, which I'm denoting as O, then we're just going to return whatever position that's in. And that way I can now very easily change the start position, put it anywhere in the maze, and this will adapt. And in fact, let's just do that by putting an O up here. Okay, let's save and let's make sure there is a path. Yes, that's fine. Okay. Continuing, we then have our queue. So we define our first in, first out data structure, and we add our starting position and the starting pause. Now I'll give you guys kind of a challenge here. If you want, try to do it by just having the path and not having the starting position. There is a way to do that. Again, I just haven't done that in this video. Then I have my visited set, keeping track of all the elements I visited. I'm saying while the queue is not empty, what I'm going to do is get the current position and the path from whatever's at the front of the queue. I'm then going to get the row and the column of the current position, and I'm going to draw out the maze with whatever current path I'm on, whatever one I've got to at this point. I'm going to check if I'm at the end. If I am at the end, then I can return the path because I found that end node. If I've not, then I need to continue looking for the end node, right? So I'm going to say neighbors equal to find neighbors, maze, row, and call. I'm going to loop through all of the different valid neighbor positions. I'm going to check if they're visited, and I'm going to check if they're an obstacle. If they are, I'll skip them. If they're not, I need to add them to the path and add them into the queue, because we need to check now if they're the end node and if we need to expand from them, right? That's how this algorithm works. Then I add them to the visited set. And this continues until we either find the path or we visit every single node that we have. So every single one of them has been added into visited that's not an obstacle, and we can't find a path. So this will end if either there's no path or you find the path. That's how that works. All right, find neighbors, pretty straightforward, gives us the valid neighbors. And then print maze. I won't explain that. We walked through that already. Okay, so that is that project. Let's just run this one more time for a sanity check that it's going to work when we change the starting node. And let's see what the shortest path is here. Okay, and there we go. We have found the shortest path. Of course, make this maze as large as you would like, and you can see, how that works. All right, so with that said, that is project number 1. Hopefully you guys enjoyed that. Definitely actually the most complicated one that we have now that I think of it. Now, though, let's move on to project number 2. All right, so now we're moving on to project number 2, which, as I said, is going to be the NBA project where we're grabbing basketball data. There's a ton of data you can get. If you're into basketball, this is going to be really cool for you. And even if you're not, you'll learn how to work with an API, how to process some data, external data in an application, kind of display that in some format, send a request, etc. So what I'm on right now is a link. It's data.nba.net/prod/v1/today.json. This is a free API. And what this gives you is links to all of the pieces of data that you have access to for free. So it's kind of weird, but this link gives you the links that you're going to look at to get specific data. So for example, if I search for, let's zoom in. Oh, that's a lot easier to see. So for example, we have this calendar, okay? So this says calendar, and it's prod v1 calendar.json. What that means is I copy what's called the endpoint, and I just tack that on. Oops, that's not what I meant to click, to the end of this here. So I paste that. So now I'm going to calendar.json. And if I hit that, it gives me a calendar that contains, I guess, some calendar data. I don't know exactly what this is doing or what this is showing, but the point is that it gives you a bunch of links for all different types of stats that you can get. So you can get like all-star roster, league config standings, league div standings, whatever you want, you can have a look at and you can grab that data, but you first go to this link and then it gives you the link to that data. That's how that works. Okay, hopefully that makes a bit of sense. I'm going to leave that open. Now, though, we want to essentially grab the data that link's providing from code. And the way we're going to do that is we're going to send a request to that link. It's going to return to us something called JSON, which stands for JavaScript Object Notation. I have an entire video on JSON on this channel, but pretty much this is a Python dictionary. That's the way you can think of it. And we can access the different key value pairs, grab the links for data sources that we want, and then send a request to those links and get data from that. So it's kind of a two-step process. We send a request to that URL. It gives us some data on the different links. We then send a request to one of those links and get the data that we actually want. And a request is essentially our computer requesting information from a remote server. We're going to send something called a GET request, which, as it says, requests information. There's other type of requests like post requests, put requests, patch, delete requests that do other types of stuff, but that's kind of beyond the scope of this tutorial. However, before we can do all of that, we need to go and install the request module. Now, the way you do that is similar to how we installed curses before. Go to your terminal and type pip install, and then requests like that. Again, if that doesn't work, try pip3. If that doesn't work, try python-m pip install. Otherwise, you can watch those 2 videos that will be linked in the description, and it should show you how to fix that. But you need the request module installed. If you're on Windows and Mac, you do need to install this. Unlike curses, it will not be installed by default. And again, just a reminder, try pip3 in case that doesn't work. And then you can try python-m pip or python3-m. Anyways, I have this installed, so that's all working for me. And let's now go in here and start writing some code. So I'm going to say from requests, import, and we're going to import get. And I'm going to say from, and this is going to be pprint, import, and we're going to import the pretty printer like that. I'll show you the pretty printer, kind of a cool thing in Python. It's built in, and it gives us a nice formatted output for JSON data. Then what we're going to do is have our base underscore URL, which is going to be equal to https:// and this is going to be data.nba. and then net. Okay, this is the base URL. And then the endpoint is going to be the specific data that we want. So I'm going to say all JSON is equal to, and this is going to be /prod/v1/today.json. And today.json is the original one we were looking at that gives us all of those links. Now, though, we want to send a request to this link. So the way we do that is we say our response, because every time you send a request, you get a response, is equal to, and we're going to say get, and we're going to say base URL. We're going to append this, or we're going to concatenate this to all JSON. So we'll have, the full URL built out. And then we're going to have a look at what's known as the JSON of this. So whenever you send a request here, you have access to .json. Again, think of this as a Python dictionary. And now we can print all of that out. However, you're going to see if I print this with a print statement. So let's try this here. If I print the response, that we get kind of this garbage in the terminal that's just impossible to read. So instead of printing it using a regular print statement, we're going to use a pretty printer. Really cool thing if you haven't seen this. So to do this, we're going to say printer is equal to pretty printer. Make sure you add your parentheses. And then we can use the printer by saying printer dot and then pprint, so pretty print. And we're going to print the response. And really, we should call this data because we're grabbing the data, the JSON associated with it. So let's say data. Okay, so let's run this. And now notice that I get much nicer formatting here. Everything's kind of separated on different lines. That's what we had before. This is what we have now when we use the pretty printer. So inside of here, we can see that we have a bunch of links. Now, these links give us access to all of these different things, right? So gamebook, lead tracker, mini box score, whatever data it is that you want, you can pretty much get all of it. So what we want is the current scoreboard because we want to get information about games that are currently going on or that are going to happen today. So what I'm going to do is try to grab this current scoreboard key and get the link that's associated with it. So the way I do this, first of all, is I need to access the links key, right? So that I can start looking at this dictionary. Then I need to access the, let's have a look, the current scoreboard. So we'll do it step by step. Let me just close this terminal and let's do this. So we have our data. Now we want to say links is equal to data at, and then links. And let's print this out. So printer.pprint and then links. Okay. So let's have a look at that. And now when I print out the links, we just get all of the links in here. And now the link that I want is the current scoreboard. So I'm going to grab the current scoreboard link. So I'm going to copy that there. And now I'm going to say that my scoreboard is equal to, and this is going to be links. And then we're going to paste in here the current scoreboard. So now let's have a look at the scoreboard. Okay, let's run this. And notice here that this is the URL. So prod v1 2022, whatever, scoreboard.json. Now that I have that, as I was saying, I need to send a request to this endpoint. The endpoint is the slash after the base of the URL so that I can get that information. So now that we have that, we have the scoreboard URL. Let's make a function here and let's say get underscore scoreboard. Okay. Let's put this inside of here. And we're just going to separate things to make it a bit cleaner. I'm going to say define get underscore links. Okay. And inside of here, we're just going to return links. And now what I'm going to do is rather than links, I'm going to say get underscore links like that. And then I'm going to access the current scoreboard. So I've just made it so I can reuse this function here. So it gets me all of the links, sorry. So now I get the links, access the specific link that I want. And now I'm going to send a request to that link. So I'm going to say get, and we're going to say base URL. And this time we're going to say plus scoreboard. Okay. And we'll say that this is response. And actually, I guess we could just do data is equal to, and then we can get the JSON. And then again, we can use the printer. So printer.pprint, and we can print out our data. Okay. So now all we need to do is call the get scoreboard function. So let's call that. And what's going to happen now is it's first going to send a request to, to the alt JSON URL. It's going to give us the links. We're then going to access current scoreboard. Then we're going to send a request to that, get the data, and print it out. So let's clear this and let's run. And notice that I get all kinds of data here, right? And this is kind of hard to read. Like there's a lot of stuff, so it's difficult to look at what the keys are. So what I like to do here to actually see how I can kind of traverse this data is I would like to print out the keys. Because remember, this is a Python dictionary. So since it's a dictionary, what I can do is just grab all of the keys of the dictionary, and then I can see what data I want to grab next. So if I run this now, and we scroll to the bottom, notice that my keys are internal, num games, and games. So I probably want to access the games. So let's clear that and just access the games for now. So now I can go JSON and games. And now let's have a look at what this data looks like. So let's run this. And notice again, I get a bunch of stuff. So now I probably want to have a look at the keys of this. So let's say data.keys. Okay, let's run this. And what does it say here? List object has no attribute keys. Okay, so what that means, sorry guys, is that the games is a list of all of the different games. So what I can do instead now is I can say for game in games, because this is a list. We just found that out. And now I can simply print the game.keys. and just break. And what that means is I'm just going to do this one time. So I'm just grabbing, the first game and printing out all of the keys associated with a game so I can view that. So now let's run this. Okay. And name games is not defined. Oh, my apologies. Let's call this games, not data. Okay. Let's clear the screen. Let's run. And now I get all of these keys, okay? All of this information I have access to for every individual game. And the games are games that are going to be happening today. That's what the games are. So now I got to pick what information I want to display, because I probably want to print out, who's playing, what the score of the game is, what time it is in the game. That's the stuff I had before at least, so I'll probably do the same here. So we can kind of pick what we want, but we have V team and we have H team. Those stand out to me as the visitor team and the home team. We also have period, and we should have clock. So I think those are the 4 ones I want for right now. So let's grab those. So we're going to say home_team is equal to, and this is going to be game at, and then this is going to be H team, right? Because that's the key we want to access. And then I'm going to say, I guess, away team is equal to, and not A team, but V team. And we can print out, I guess, the clock and the period as well. We'll say clock is equal to game clock, and we'll say period is equal to game period. And now we don't need to use the pretty printer because we're just going to print these on one line, and we will print an F string, and we can say home team versus, and then away team. And then we might as well just print the clock and the period as well, just to have a look at what those are, and then we'll continue from there. Okay, clock and period. So if you're unfamiliar with this, an F string allows you to embed expressions directly inside of a string when they're in curly braces. So, I mean, this is pretty intuitive, but an F string only works in 3.6 plus, so Python 3.6 plus. So I'm just putting the home team versus away team, comma, clock, comma, period, just so I can see what those look like. And I'm going to do that for every single game. So just to separate these a bit then, let's add a bit of a separator just so that we can see the difference in games. Okay, that's clear. Let's run the code, and notice that I get all of this data, okay? So for each team, I have a team ID, a try code, wins, losses, series wins, series losses. I get a bunch of data, right? And then the score of those teams, because I guess some of these games are actually happening right now. So what I can do is print out the try code if I want to see, the actual name of the team, and then I could print out their score as well. So let's try doing that now. So for our home team, that's fine. Now we're going to say home team, and inside of here, we'll say try code. And for the away team, same thing, we'll say try code, just to clean it up a little bit. So let's run this now and see what we're getting in terms of the difference. So now we notice we actually get the abbreviations for the team. Then we're looking at, what was the next thing we were printing? The clock. Okay, so 44.1 is what's on the clock for this one. And then we have the period, and it says what the current period is for the games that are currently going on. Okay, nice. So let's get rid of clock and period. So those are the teams. Next thing that I want to print is the score of each team, right? So I'm going to print F, and then this is going to be the home team, and not the try code, but the score. This is the score in the current game. And then we'll print the away team and the score as well. And so now we get the teams that are playing as well as their scores in the game, and then we can print the clock and period after that. Okay, so let's clear. Let's run, and notice here that we get, I guess, what is that? Chicago, I don't know what these teams are, but something 17-19, 31-22, 14-19, etc. Great, and then here we're just getting a hyphen because these teams are not yet playing, and 0-0, I guess those guys just started. Okay, continuing now, we want to print the clock as well as the period. So let's say print, and we'll print F, and I guess we'll go, we should probably do, should we do clock or period first? Let's go clock, period, and then we'll see what keys we have on those. So let's run this. Okay, and we get current, so that's what we want to access for the period, and then it looks like the clock just gives us a value, so that's fine. We can just grab the clock itself. Okay, so let's go clock and then period, and we want to get current, like that. Okay, let's run this again. And now notice that we get 32.0, and then that's period 1, and then 142, period 1, 409, period 1. You guys can format this better. I'm just giving you the basics, obviously. Okay, so that's what we wanted for getting the scoreboard. Now, we also can get a bunch of other data, and like I showed you, we can get stats for the teams, So their points per game, I guess their points allowed per game. There's all these different stats. I'm not a huge basketball guy. I just thought this would be cool. But let's write one now that gives us the teams and we can view their stats. And like I had before, we will rank them based on points per game. So to do this one, we're going to want to look at get links again. So let's not call get scoreboard. Let's call get links. Okay. Let's clear this and let's run the code. And let's see what links we have for stats. I didn't print, sorry, need to print this. Let's print get links. And actually we should probably use the printer to do this. So printer.pprint. Okay, so let's have a look here. And these are all the ones that we have. Now, let me remember which one I was using. I think it was league team stats. Yeah, league team stats leaders. Okay, this is the one that I want to get stats. Of course, there's a lot of other ones. So I'm going to copy that key. And now we're going to write another function. I'm going to call get underscore stats. Okay, that's fine for now. And I'm going to say stats is equal to, and then this is going to be get underscore links. And we're going to reference this right here, the league team stats leaders, okay? Then we will send a request. So let's just copy this. And rather than games, I guess this is going to be teams. And we'll have the base URL plus the stats. And then .json, and then we want to print out all of those keys so we see what we have access to. So let me take this in here, and rather than get links, we'll print out, we should really call this data, so let's call this data. Okay, now let's call get stats, so get stats like that. Okay, let's run this, and let's see what we get. And notice we get a lot of information. Okay. I want to print out just the keys. That's my bad. I meant to do that. So let's do .keys. And let's see what we actually get for that. Okay, scroll down and we get league. Okay, so that's the only key. So let's access league. So let's just put league here. There's internal as well, but we don't care about that. That's some other data. Let's see what keys are associated with league. So let's run that. We have standard, Africa, Sacramento, Vegas, Utah. I'm assuming we'd want just the standard league. Okay, so let's grab standard. Okay, let's run that. And for the keys, we have season year, preseason, regular season, playoffs. I'm assuming we probably want regular season, but again, you can change this if you want. So let's now grab regular season. Let's print that. And we only have the key teams. Okay, so now let's grab teams. And then this will be called teams. Let's see if there's any keys for teams. So let's run this now. And it says, oh, data is not defined. So let's change this to be teams. Okay. And rerun. List object has no attribute keys. Okay, so this is a list, meaning that if we want to grab the keys for each team, we can just do something like teams0.keys. And if we have a look at this now, we get all of these different pieces of information for the stats of each team. So I can get the nickname, the name, the team ID, team code, abbreviation, min, FGP, TPP. I don't know what a bunch of these mean, but I know PPG is points per game. So that's the one that we're going to use because I know what that means. Anyways, those are the different keys we can get for each team. So now we can loop through every single team and we can print out information for them. So let's do that. So let's say for team in teams, and then we'll grab the names. Say name is equal to team name. What else do we want? I guess we'll get the ID. We'll say the ID. Actually, no, I don't need the ID. We'll just go with name. And I suppose we get the nickname as well. Nickname is equal to team nickname. And let's go PPG is equal to team and then PPG. Okay, and then let's just print. For now, we'll do an F string and we'll print the name, the nickname, and the points per game. Okay, so let's have a look at this now. Let's clear and let's run. And there we go. Okay, so apparently we have a bunch of teams here that are not in the regular season or don't have a rank or something. So we'll have to filter those out. We'll do that in a second. But for now, we have the all the teams, right? So we have the name, we have the nickname. We can choose which one we want to use. And then we get average and we get rank for points per game. So this is where it gets a little bit more complicated. I want to display these teams in the order of their rank, right? So I want rank 1 to be at the top, and I guess rank 29, 30, whatever, to be at the very bottom. But I also need to filter out these guys because I guess there are a bunch of teams that we don't really need in our data set. I don't know why those are being returned to us. So the first thing I'm going to do here is I'm going to filter all of the teams that have a name of team. So I'm going to do that. Say teams is equal to filter. I'm going to say lambda x. I'll explain this in a second. Don't worry. And I'm going to say x at team like this. does not equal, and then we're going to say team, because anyone that had the name team was like a blank team that we didn't really need, and then we'll do this on teams. Okay, so what the filter function does is it will run a function against every single element in our teams. In this case, that's what we're passing. And if the function returns true, it will keep the element. If the function returns false, it will remove it. So this is an anonymous function. That's what a lambda function is. This is our parameter, essentially the function called x. So I write lambda x, and then I say colon x team does not equal team. I'm saying let's grab whatever the team key is of every one of our dictionaries. And if it is not equal to team, then we will return true. So like this expression returns true or false. So if the function returns true, we keep the element. If it returns false, we don't keep it. Hopefully that makes a bit of sense. I can't really explain it more than that. However, when you have a filter function here, it returns a filter object, not a list. So you just need to convert it to a list. Okay, so now that we have that, let's just run this again. And you should see that all those kind of empty teams will be removed. So let's run it. And key error team. Oh, sorry, not team. This needs to be name. Okay, let's fix that. Let's rerun. And there we go. So now all the ones that had just team are removed. Now what we need to do, though, is sort our teams by their rank in their points per game. So to do this, we're going to say teams.sort, and we're going to say key is equal to, and again, we're going to put an anonymous function. We're going to say lambda x, and then this is going to be x ppg for points per game, and then this is going to be rank like that, and this is going to be int. Now this is going to sort in ascending order. So we're going to get rank 1 first, rank 30th last. Now the reason I'm doing this is because points per game is a dictionary containing the rank and the average. I want the rank, so I'm grabbing points per game rank for every team, converting that to an int. So then we sort it as an integer, not as a string, because notice these are string values, right? And that's how this works. You can pass this key function, and that's what you're going to sort every element by when you're sorting. Now let's run this. And notice that we're going to have all the ranks in the correct order. Now, of course, I don't want to display, this weird dictionary. I'd prefer to display the following: PPG and then AVG like that for the average. So now if we rerun this, we get the average number of points that each team scores per game, and we get them ranked from 1 to 30th. Lastly, if we want another touch here, we could do the following. I'm going to say I plus 1 dot, and I'm going to say for I comma team in enumerate teams, and now it will say the rank beside each team. So let's do that now, and let's run, and notice that now I get my rank, and I also could have just done PPG at rank as opposed to doing I plus 1, but this works as well. Okay, so that is going to wrap up this project. Let me quickly walk you through it. So we start by defining the URL that we're going to send our request to. We had to import and install the request module. We set up our pretty printer. We have get links, which gives us the link we're going to send our request to get specific data. We then have this function to get the scoreboard. That is the games that are currently running. And so we have current scoreboard. We get the JSON. We grab all the games associated with that. For every single game, because this is now a list, we loop through, we get the home team, the visiting team, the clock, and the period, and then we display this data. And of course, you can display this nice, so you can get some more info. I thought this was good enough for the tutorial. Then we have our get stats function. And get stats is going to grab the league team stats leaders. It's going to do the filtering, it's going to do the sorting, and it's going to go through and display all of the teams ranked by points per game. So I just called get stats to run that. You can call get scoreboard to run this. You can run both of them. You could write a little program that asks the user which one they want to run. I'll leave that to you guys. Now we're going to move on to project number 3. All right, so now we are moving on to project number 3, which is a currency converter. Now for this project, we need to go to this website, free.currencyconverterapi.com, to get an API key that we can use with this API. Now this is a free API, as it says in the name. You are rate limited, which means you have 100 requests per hour. You can do a maximum of 2 currency pairs when you're getting the exchange rates per request, and you're allowed to go back 1 year in history. Now you can pay for a premium version of this. Obviously, we don't need to do that for this tutorial, though. We just want to get the exchange rate data. Now, this data is updated, I believe, every 60 minutes when you're on the free version. I think if you go to the paid version, you get it every minute or 60 seconds or something like that. Again, it doesn't really matter for this tutorial. Anyways, go to the website, link in the description, click on Get Your Free API Key, enter your email, it will send you the API key, but make sure you verify your email, because if you don't do that, then it won't activate your API key. Anyways, I already have my key, and you don't want to share this with anyone. Of course, it's the video. I don't really care. I'm going to have to share it with you. But what I'm going to do is make a variable here in a new file called API key, and I'm going to paste in my key, which I'm just going to grab from my other screen. Now, while we're at it, we're going to paste in another variable here called base URL. Now, this is going to be equal to a different URL than you just saw. It is free.curconv.com. So that's the URL we want to be sending our request to for this project to get the up-to-date currencies, right? Okay, then what we're going to do is say from request import get. Now, if you were not following along with the previous project, which is fine, what you need to do is install requests. So pip install requests like that. You can also try pip3 install requests. And if that doesn't work, try python-m pip install. Lastly, you can try python3-m pip install. If that doesn't work, there is 2 videos linked in the description that will show you how to fix that command, one for Mac and one for Windows. Okay, now that we have that, we're just going to import the pretty printer as well, just so we can use that again. We used this in the last video. Sorry, so from pprint, not last video, last project, we are going to import the pretty printer. Okay, so this API works a little bit differently than the last one. We need to send what's known as some query parameters when we want to get some specific data. And the first thing I'm going to do here is show you how we can get a list of all of the currencies, and then how we display those currencies. Then we can get the exchange rates and all of that stuff. For now, though, I'm going to set up a printer. So I'm going to say printer is equal to pretty printer. Again, if you weren't following with the last video, then what this allows you to do is get some nicely formatted output for your JSON. The JSON is essentially a Python dictionary that's going to be returned to you when you send a request to a URL. Okay, so now that we have that, let's get the currencies. The way that we get the currencies is we say endpoint is equal to, and then I need to copy this in. So let me just copy this from my other screen. And this is going to be API/v7/currencies and then question mark. Now, this starts what's known as a query parameter. A query parameter is essentially a parameter, some data that you're going to send to the URL. And in this case, what we need to add is our API key. So we're using an F string available in Python 3.6 and above. We're embedding the API key directly in here, and that's what's going to allow this to work. If you don't have the API key, then this won't be validated and you won't be able to send a request. Now let's actually do this in a function. So I'm going to say define get currencies like that. And we're going to say this is our endpoint. And we're going to say that our URL is equal to our base URL plus our endpoint. And then we're going to say that our data is equal to, and this is going to be get. We're going to send a get HTTP request to this endpoint. So we're going to say get URL and then .json like that. And for now, we're going to say printer.pprint, standing for pretty print, and we're going to print out the data, and we'll just call the get currencies function. Okay, so that's all we need for now to look at the currencies. So let's run this. And no module name request. Okay, it needs to be requests plural. My apologies. Let's run this again. And notice that we get all of our different currencies, okay? So when I have a look at what we're getting returned here, we get a key that says results. Now, again, this is just a Python dictionary. That's the way you can think of it. Really, it's JSON, but it gets read in as Python dictionary. So I can access this results key, which is then going to give me a dictionary that has keys for every single currency. And then the value of all of those currencies is going to have an ID, a currency name, and optionally a currency symbol. So I want to be able to display that data to the screen. So what I'm going to do here is from this function, I'm going to return the data. And then this is going to be at results like that. And I'm also going to sort all of the results before I return them. So I'm going to say that this is results. Okay. I'm then going to say here data.sort. So actually what I'm going to do here in a new line is I'm going to say data is equal to, and then this is going to be the list of data.items. The reason I'm doing this is because data right now after I get results is going to be a dictionary, as we can see. I don't want it to be a dictionary. I want it to be a list. And the reason I want it to be a list is so that I can sort it by the different currency names. So I'm going to convert it into a list by getting all of the items. The items will give me tuples that contain the key. So would that be the currency and then the dictionary associated with each currency. Then I'm going to sort this By default, it will sort by the first item in Python. So it'll sort by the currency name, and then I'm going to return my data like that. So now I can say down here, data is equal to get currencies, and I can say printer.pprint and data, and hopefully this will look a little bit cleaner now, and it should be sorted. So let's clear the screen. Let's run this. And then notice we're getting tuples here, right? Where it contains the currency, I guess you could call it ticker, and then the information associated with that currency. And it's in alphabetical order based on, I'm going to call it the ticker or the ID, whatever, for the currency. So now what we want to do is write a function that can display this in a much nicer format. So we're going to say define print underscore currencies. We're going to take in our currencies and we're going to loop through them and print them out. So we have data there. That's fine. So now we're going to say for currency, and then this will be, well, we should probably spell currency correctly. So for currency in currencies, we are going to grab the name of the currency. So if we look here, we see we have currency name. We want the ID and then potentially the currency symbol, but not all of them have it. So we're going to have to write some code for that. Okay, so let's say name is equal to, and then this is going to be currency, and I believe it's currency name. And then we want the ID. So we're just going to say underscore ID. I don't want to use ID because that's a built-in keyword in Python. And this is going to be currency. Actually, no, it's just going to be ID. Okay, and then the symbol will be, so symbol is going to be equal to currency, and then this is going to be .get. And we're going to try to get the currency symbol like that. And if it does not return a symbol, then we're just going to get an empty string. So when you use .get, that will try to find this key in the dictionary. If it exists, it gives you the value. Otherwise, it gives you the default value, which is an empty string, which I'm passing right here. Okay, now that we have that, we can print this out. So we're just going to print an F string again, and we'll have the ID first, because that's going to be the 3-letter symbol. Then we will have the name, and then optionally, we will have the symbol there. Okay, hopefully that makes sense. Let's now call this. So print underscore currencies. Let's pass our data, and let's see what our output looks like here after I clear the screen. Okay, let's run it. And tuple indices must be integers or slices, not string. My apologies, guys. So we're going to say for currency, let's do this, for name, comma, currency, and currencies. The reason we have to do this is because this is a list of tuples. Forgot about that. So now if I run this, it should be good. And there we go. Now we fix the problem. So we can see that we get our little ticker, currency. If there's a symbol, it will display the symbol. If there's not a symbol, then, well, we don't show it. Okay, nice. So now that we have that, we want to write something that can get an exchange rate. So I'm going to say define exchange underscore rate, I guess, like that. And for the exchange rate, we need 2 currencies that we want to get the rate for, right? So we're going to say currency 1 and currency 2. Now, these currencies are going to be the IDs of the currencies we listed out. So like CAD, USD, whatever. The IDs is what we need to pass to this function for this to work. Now, the endpoint for this, I'm just going to copy it in here, is going to be the following. So endpoint is API/v7 convert $Q, okay, for query, right? We're going to say is equal to currency 1, and then notice this is underscore currency 2. So a little bit weird how this works, but for this specific URL, you pass the first currency underscore the second currency, and that's the pairing that you want to get information about. Now you can pass multiple pairings, like I could do USD underscore CAD here, and it would give me both of the results. Now we're just going to do one at a time, and then you say and compact equals ultra, and API key equals API. When you do compact ultra, gives you the most compact version where it's just going to give you the exchange rate. And then, of course, you need your API key as well. So we're going to embed that in this way. Hopefully that makes sense. Now we're going to send a request here. So we're going to say URL is equal to base URL plus endpoint. We're going to say response is equal to get URL.json. And sorry, not .json. We're going to say data is equal to response.json. And let's now just print this out. So let's go printer.pprint. And we're going to have to handle potential errors that can occur here if you pass invalid currencies. So for now, though, we can comment this out and we can just call the exchange rate. And let's pass this with USD and CAD, and it will give us the exchange rate between USD and CAD, not from CAD to USD, although I guess you could go both ways. Okay, let's run this. And notice that we get USD CAD and it's 1.259025, looks about right. And if we pass the second pairing, it would have given us this key for whatever the second pairing was and then the value. Hopefully that is clear, but that's what we're getting from that. So what we need to do now is essentially check to make sure that this actually worked. And the reason I'm saying that is because if I pass something like, random string here and I run this, notice that my data is empty because there was no pairing with that name. So what I'm going to do here is I'm going to say if the len of data is equal to 0, then I'm just going to print out invalid currencies. I guess we could just do, I guess that doesn't really work. We'll do invalid currencies, and then we'll just return. Otherwise, though, we want to get the pairing, and we're only going to have one pairing here and here. One pairing here and here. Okay, interesting how I said that, but we're going to return data, and then this is going to be dot items. Actually, not dot items, dot values. And we're going to convert this to a list first of all, because when you get the values, it gives you kind of this special object. And then we'll grab the 0th value, and we can, actually that's already a float, so we don't need to convert that. Okay, so let's now say rate is equal to that, and then print rate. Okay, and then this will be USD. So what I'm doing is I have my endpoint, right? I have my URL. I'm getting my response. I'm getting the data associated with that. I'm saying if the len of data is 0, then print invalid currencies. I also realized that we can just clean this up. So let's just make this data like that. Now, if the length is 0, that means, well, we didn't have a valid pairing. So we print that out and we return. Otherwise, though, we're going to convert all of the values. It's just going to be one value, really, to a list. We're going to grab the 0th element, which will just give us whatever the rate is. And then we can print that out here. Okay, so let's run this. And notice we get 1.259025. Nice. Okay, so now that we have gotten that, maybe I want to add some output in here, actually, that tells me a bit nicer what the rate is. So let's do that. I'm going to say, actually not print, I'll say rate is equal to this. And we will return the rate, but before I return the rate, I'm just going to print out. And we'll do an F string here, and we will say that, what is this going to be? Currency 1, okay, to currency 2 is equal to rate. I don't know if this is exactly the way that I would write this, but I think that's fine. Like USD to CAD, for example, is this rate. Yeah, you know what? For now, we're just going to go with this. We'll say is equal to that. That's fine for me. Okay, so let's just run this one more time. And notice that I get USD to CAD at 1.259025. Okay, perfect. That works for me. Now that we have that, we're going to write one more that is going to take a dollar value and convert that dollar value to the other currency. So we're going to utilize this function, but I'm going to say define, and then this is going to be, I don't even know what I would call this here. I guess convert. And convert will take currency 1, currency 2, and an amount. Now in here, we're going to say the rate is equal to exchange rate of currency 1, currency 2. And I'm going to say if the rate is none, so if we're returning from here, meaning we had an invalid currency, then we're just going to return. We don't need to do anything. Otherwise, though, we're going to try to convert the amount that was passed here to a float. So I'm going to say try. And then I'm going to say amount is equal to float amount. I'm going to say except. And then what I will do is say print invalid amount. So if you pass like a string amount, for example, here, something that I can't convert to a float, I say invalid amount and then just return, so that way we don't have any issue when we try to do a multiplication, which you're going to see in a second. Okay, so we try that. If that doesn't work, we say invalid amount. Otherwise, we're going to say converted underscore amount is equal to, and this is going to be rate multiplied by whatever the amount is, right? And then what we can do is print with an F string here, and we can say, let's say amount, and then currency 1, and let's just say is equal to, and then we'll say converted amount, currency 2. Okay, and then just because we might as well just return the converted amount. Okay, so now we have 4 functions: get currencies, print currencies, exchange rate, and convert. So now what we want to do essentially is just write a program that keeps asking the user for a command and allows them to quit, but they can type in a command and do whatever they want with the currency converter. So I'm going to say define main. Inside of here, I'm going to say currencies is equal to get currencies. Okay. And then I will just print out like a little welcome message. So welcome to the currency converter. Okay. Exclamation point. And then we'll print the different commands. So I'll say list the different currencies. Okay. We'll say print, and then this is going to be convert, convert from one currency to another. Okay. And then print, we'll just call this rate, get the exchange rate of two currencies. Okay. Now that we have that, let's just do one empty print statement just as a separator, and then we'll say while true, and we're going to ask them to enter a command. So we'll say the command is equal to input, and we'll say enter a command, and we'll just say that they can type Q to quit like that. Okay, so now in here, we're going to say, actually first let's convert this to dot lower, just so that we can check, even if they type something uppercase, we'll still get the command. So first we'll check if they quit. So if command is equal to Q, we need two equal signs here, then we can just break out of the while loop. So let's break. We'll say elif the command is equal to list, then simple enough, we can just print the currencies. Okay, so print currencies like that. That's all we need for list. We'll say elif the command is equal to, and then I guess we can handle convert. Then we need to ask the user for two currencies as well as an amount. So we're going to get currency 1, which is equal to input, enter a currency name. Okay, actually, let's say ID. All right, then we'll convert that. Actually, we're going to convert it to dot upper, not dot lower. Now let's copy this again. So let's say that's currency 2. Actually, we'll say enter a base currency ID, enter a currency to convert to. Maybe we'll just do this. I think this reads a bit better. Enter base currency, enter a currency to convert to, and then we want one for amount. So I guess I could have just written this from scratch. We'll do this in between. I'll say amount is equal to input, enter an amount, and then we'll say in, and this will be in the base currency. So we can say in, and then currency 1. Okay, and well, we don't really need to convert that to dot upper because it's just going to be at a value. Once they do all of that, then we can call our function, which is convert, and we can pass our values. So we can say convert like that. And we pass currency 1, currency 2, and amount. Okay, lastly, so we say elif the command is equal to rate. Then we just want to get the two currencies. So let's grab currency 1 and currency 2, and let us call exchange rate. So exchange rate of currency 1 and currency 2, and else we'll say print unrecognized command. Okay. I think that is all we need. Now we need to, of course, call the main function. Okay, let me zoom out a little bit just so you guys can read a bit more. So we have our main function. We're getting all the currencies. We're just printing a little welcome message, and then we're running a while loop, and we're saying while true. We're going to ask them to enter a command, Q to quit, of course. If they enter Q, we will break, so that will quit. If they enter list, we'll print the currencies. If they enter convert, we'll ask them for the information we need. Then we will convert, and convert here. We'll do everything we need and print out the output. Then we have our rate where we get our two currencies, and same thing, we get the exchange rate, and that will handle printing out the output as well. So I believe that's it. Let's run this though and test it out. So run, and welcome to the currency converter. Let's zoom in a bit here. List, convert, and rate, enter command. So let's try list. Okay, there we go. List everything out. Let's try to do the rate. And let's do USD and ZAR, okay, and gives us 14.944, okay. Let's now try, was it exchange? No, it was convert. Convert, enter a base currency, let's go USD, enter an amount in USD, let's go 1,000. Let's go XOF, which is one I just saw up here, West African CFA franc, okay. And there we go, gives us the conversion. Nice, and then if I hit Q, I can quit, and that is all the program needs to do. All right, so with that said, I think I'm going to start wrapping up the video here. That was 3 mini Python projects for intermediate programmers. Not overly complicated, not super simple, short period of time, but also allows you to create something kind of cool. I think these programs are somewhat useful and definitely a good kind of introductory project, something you can build onto, and hopefully a good learning experience for you guys to understand how API works. Maybe you learned about the Pretty Printer, maybe you learned about the Curses module, whatever. Hopefully I gave you guys some value in this video. With that said, I will give one last plug to Programming Expert. If you guys want to get better at programming, that is my programming course. You can check it out from the link in the description. Use discount code TIM. If you guys enjoyed this video, make sure to leave a like, subscribe to the channel, and I will see you in another one.